Welcome back to our YouTube channel Aman Codes. In previous episode, we have discussed about the binary number system and decimal number system. In today's episode, we are going to discuss about octal number system. These number system values are stored by INT data type. So octal number system is understandable by the microprocessor kits during assembly program execution. These microprocessor kits are familiar with ECE background students. Octal number system is understandable by the microprocessor kits during the assembly program execution. So when assembly program is executing, at that time microprocessor kits can understand these type of octal number system. So the octal number system contains the following. See, in octal number system, the digits are from 0 to 7. So total digits are 8. The number of digits is known as base. So base is 8. So oct means 8 here. So that is why it is called as octal number system. So base 8 literals are called as octal number system values. Which are the base 8 that all values are comes under octal number system values only. So in programmatically, the octal number system must preceded with the letter 0 small o or 0 capital O. So in in previous episode, we have a notation for binary that is 0 small b or 0 capital B, right? So in octal number system, we have one other notation for octal number system that is 0 small o or 0 capital O. The syntax is look like variable name is equals to 0 small o and octal data. Even though we store octal data, internally Python program execution environment converts this octal data into decimal number system data because Python is one of the high level language. So even though we specifies the octal data, the Python internally it converts that octal data into decimal number system in order to understand by the end user. So have conversions decimal number to octal number and octal number to decimal number. So let's see this decimal number to octal number. So for example, we take decimal number as 23 of base 10. Base 10 means it is a decimal number. So we have to convert this 23 of base 10 to base 8, x of base 8. So this base 8 stands for octal number. 23 LCM. So the base is 8, right? So that is the reason we have to do LCM with 8 only. So we take 8 to the 16 and the remainder is 7. Next, we have to take 8 only because this is octal number system, right? So 8 zeros are 0 and the remainder is 2. So LCM is done. So we have to take from bottom to up direction. So including this value also, we have to take from bottom to up direction. So let's see 0, 2, 7 of base 8, right? So this 23 decimal number has converted into base 8 octal number. Now let's convert the octal number to decimal number. So take the same number 0, 2, 7. Ignore this 0. So take this same octal number 27 of base 8 and convert that into base 10. So same we have to take freely 2 and 7. So in previous video we have converting the binary to decimal. So binary base is 2, we have took 2. So here the base value is 8. So we have to take here 8. So here also 8. So to start from 0 and then 1. So we have to multiply these two and add with all these. So let's see. So 2 into 8 power 1 plus 7 into 8 to the power 0. So if we calculate this, 2 8s are 16 plus anything to the power of 0 means 1. So 7 ones are 7. So that implies C. 7 plus 6 is 13, 3 and 1. 1 plus 1 is 2 of base 10. See, the octal number system value has converted into decimal number system value. We see this in practical way. If we come here, I am storing A is equals to, we have one notation for octal number, that is 0, small o or capital O. First we are using small o. So 2 7. So if we execute this, we are trying to print A. So A comma type of A. So see this. So sorry, mistake. So type of A. See, we can store octal number system values also. Why it didn't print like this means Python is a high level programming language. So that is the reason it directly convert the octal number system values to decimal number system values 23 in order to understand by the end user. So if we take A is equals to 0, capital O of same 27 if we take. Next I'm trying to print that. So see, so capital O is permitted, small o is permitted. So this is a practical explanation of octal number system. INT can store octal number system values. So next we are stepping into hexadecimal number system. So next is hexadecimal number system. So hexadecimal number system use development of operating system and languages. In order to develop an operating system, we want to use hexadecimal number system. In order to develop an language, then we have to use hexadecimal number system. In hexadecimal number system, we have 0 to 9 digits. So 0 to 9 digits means in total 10 digits, right? So hexa means 16. In order to complete this 16, we are taking alphabets also. So we have total 6 alphabets. See, A, capital A, or we can use a small a. So we are declaring that A as 10. So next B, next C, D, E, F. So hexadecimal number system contains digits and also alphabets. The digits are from 0 to 9. Alphabets are from A to F. We can declare that in uppercase or in lowercase. The digits plus alphabets are total 16. So here base is 16. So base 16 literals are called hexadecimal number system values. So anything of base 16, it comes under the hexadecimal number system values. Here, programmatically, the hexadecimal system must preceded with the letter 0x or 0 capital X. So here also we can use small x or capital X. This is a notation of hexadecimal number system in order to declare this in practical way, in programmatical way. So the syntax comes like this. Variable name is equals to 0 lowercase x hexadecimal data. So here uppercase x hexadecimal data. Even though we store hexadecimal data, internally Python execution environment converts this hexadecimal data into decimal number system data because Python is one of the high level language. So see here, decimal number system to hexadecimal number system and hexadecimal number system to decimal number system. So let's see. For example, we are taking 172 as a decimal value. So take 172 2. What is a base for decimal value? That is 10. And I have to convert this into base of 16, right? Hexadecimal value base is 16. So I have to convert this 172 with base 10 into the hex of base 16. So same thing. We have to take the LCM of 172. So here in the hexadecimal conversion, we have to take the base of hexadecimal. So here 16. So 16 tens are you take directly. 16 tens are 160. So the remainder is 12, right? So 12 is a remainder. And you take directly 16 zeros are. So if we take 16 zeros are 0. So the remainder is 10. So we have to take bottom to top direction only. In hexadecimal number system, 10 stands for A and 12 stands for C. So see here 0, A, C. This is the decimal number has converted into hexadecimal number system value. I'm taking same hexadecimal number value 0, A, C of base 16. I have to convert this into base 10. 0, A, C. So if we ignore 0 also no problem. So if we take like this AC, we are converting hexa to decimal, right? So we have to take this base. So 16 and here also 16. So same like previous 0 and then 1. We have to multiply with these two and we have to add this all. So in hexadecimal number system, A stands for 10 and C value is 12, right? So take same values. A is equals to 10, right? So here do 10 into 16 to the power of 1. So plus same next C is equals to 12, right? So 12 into 16 to the power of 0. So if we simplify this, 16 tens is 160 plus 16 to the power of 0. Anything to the power of 0 is 1. So here it is 1, right? 12 ones are 12. So that is equals to 172 of base 10. See here, we have converted the hexadecimal number into decimal number. So let's see in practical. A is equals to, I am declaring 0 x AC. I can use small a or capital A. I can use small c or capital C. I can use a small x or capital X, right? So see, I'm trying to print that value and type of that value also. So see, even though I have declared here hexadecimal data, so the Python execution environment is directly converted this hexadecimal data into decimal number system value. Why means Python is a high level language. In order to understand to the end user, the Python automatically converts this hexadecimal data into this decimal number system. So the main point is int can store hexadecimal number system values also. So let's see, we are declaring capital X, small a and small c. See, it take, right? So I'm trying to print a. So same answer. We can use uppercase or lowercase while declaring hexadecimal values. So this is all about number systems. In total, we have four type of number systems. They are decimal number system, binary number system, octal number system, and hexadecimal number system. Int data type can store all these number system values. So this is all about int data type. So in next episode, we are going with float data type. So that's it for today's video. Thank you so much for watching.